Okay, here's a word problem. Let's work through this situation. To make copies of blueprints, Vantage Reprographics, it's a fun name, Vantage Reprographics charges a $5 setup fee. So we've got the setup fee. It's $5 plus $4 per copy. So $4 for the first copy, times the second, times the third, right? So we've got the setup fee, we've got the cost per copy times the number of copies. Here's our model in words, the setup fee plus the copy fee. That's going to be the total price. Total cost, total price, whatever. Okay, Myra can spend no more than $45 for copying her blueprints. So here's going to be our total cost. That can be no more than $45. Right? We're not saying she has to spend exactly $45. It means she can spend no more than $45. Her upper limit is $45. It could be exactly $45, but hopefully it'll be less than $45 and she'll have money left over to pay for something else. Right? She's copying blueprints. This is all she's got available. What numbers of copies will allow her to stay within budget? So we have an equation. I've got my fixed 5 plus 4c less than or equal to 45. Subtract my 5, 4c less than or equal to 40, right? Even before she starts making a single copy, she has to pay that $5 setup fee no matter what. So she only has $40 left per copy. So divide that by 4. 10. If she gets 10 copies, 10 times $4 is $40. Plus the $5 setup fee, she's used up all her money. If she makes fewer copies than that, great. She won't spend as much money. So what numbers of copies will allow her to stay within her budget? What's her name? Myra. Myra can make up to 10 copies. And I think we all understand what that sentence means in the real world. We're good. Now, in terms of showing this algebraically, this statement doesn't give us any context, right? If I just graph c is less than or equal to 10, I'm going negative infinity up to 10. I can use the bracket here instead of the dot, same thing. Well, that's not what's going on here. Myra's not going in and making negative 75 copies in order to get a refund. Right? She's not making 9.3 copies. Right? The practical situation here is Myra could make 0 copies, not spend any money. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 copies. That's her whole list here. So think in real terms about what seems appropriate. All x such that x is less than or equal to 10 is not really appropriate for this situation because there are lots of numbers that are less than 10. She can't make pi copies. She can't make 9.2 copies. She can't make negative 7 copies. It's got to be a whole number, a positive number that's less than or equal to 10. So in your textbook, they'll usually give a clear way that they want you to write your answer. When you're dealing with this in real life, these are really the only two appropriate ways to answer the question. This is not an answer to the question, even though it's what's guiding us to our final answer. Same thing over here. This doesn't make sense for the context. This doesn't make sense for the context. Even though algebraically they are correct. All right, let's try a different one. On July 1st, a pond was 25 feet deep. Since that date, the water level has dropped 2/3 of a foot per week. All right, whenever we're talking about physical movement, I love drawing a picture, right? The pond was 25 feet deep, so I've got 25 feet below, I guess, the surface of the water. So I've got the water here, the pond is going down here, here's the bottom of the ocean, not the ocean, the pond. All right, I've got the fish swimming in there. Since that date, the water level has dropped 2/3 of a foot per week. For what dates will the water level not exceed 21 feet? We've got to think. There's a lot of double negatives. Dropping, not. Okay, let's see what's going on here. For what dates will the water level not exceed 21 feet? So the water level, let's make this a little skinnier here. The water level not exceed, so not greater than 21 feet. Now we tend not to use the not with the inequality symbol, so if it's not greater, it could be less, or it could be equal to, right? Not exceed, it could be 21, 21 does not exceed 21, or it could be less than 21. So I guess we're not really concerned with 25 being a negative number being below the surface of the water. We're just saying this distance is 25. Right? Another way to think about it is if we call the bottom of the pond 0, that water level is 25 feet above it. Right, we've got our fish in here, just like we had them in here. Right? So it's not that the ground is moving higher. The water level is dropping. It's evaporating. Maybe there's a stream running off of the pond and there hasn't been rain to replenish it. So the water level is dropping by 2/3 of a foot per week. So I'm starting at a water level of 25. That water level is dropping. The pond is getting shallower by 2/3 of a foot per week. And let's just use a single variable there. 2/3 of a foot per W for week. Right. Is 25 less than 21? No, it's not starting out less than 21. It's starting out where it does exceed. For what dates will the water level not exceed 21? Well, the first date is no good. Right? The first date the water depth exceeds 21. 25 is more than 21. Now, there are certain times where we're just counting, right? 1 week to the next week to the next week. We're just looking at weeks as integers. Maybe we can just count, right? 25 minus 2/3. The very first one, let's go small here. 25 minus 2/3, that's 24 and 1/3. Minus another 2/3, 1/3 minus 1/3 is 24. 24 minus the second third, that's 23 and 2/3. So that's 1 week. After 2 weeks, we're at 23 and 2/3. Another week, we drop 2/3, so we're down to just 23. And so on, right? We're getting pretty close to 21. If we end up hitting exactly 21, that could give us an exact number of weeks. But that's kind of tedious. Subtracting fractions here, that's a pain. So let's just solve this for W. Right? Use our algebra skills and techniques we've already developed. So subtract the 25. I was supposed to switch to red there. There we go, subtract the 25. 25 minus 25 is 0. I get the opposite of 2/3. W less than or equal to 21 minus 25 is -4. All right, now multiply by the reciprocal here. I want the 2 to cancel. I want the 3 to cancel. I want the negative to cancel. Negative times negative is positive W. 3/3 is 1. 2/2 is 1. 1 times 1 times W is 1W. Except I multiplied by a negative, so this is actually reversing. This is greater than. Multiply this by 3/2, so multiply this by 3/2. 4 divided by 2 is 2. 2 times 3 is 6. That was actually -3/2, so it's -3/2. Negative times negative is positive. So W is positive, or greater than or equal to positive 6. In other words, as this process continues, after 6 weeks, my level will be at 21 feet. If I keep dropping by 2/3 of a foot per week, after 6 weeks exactly, my water level will be at exactly 21 feet. And 21 feet does not exceed 21 feet. So on that very next week, after exactly 6 weeks, I'm good. So for what dates will the water level not exceed 21? I need a date that's 6 weeks after July 1st. And from that date forward, well, assuming this water level is dropping consistently, and that's certainly not realistic that the water level would drop at such a precise rate over months. But that's what they're setting up for their situation. So we've got July 1st plus 6 weeks. So July 1st plus 31 days gets us to August 1st. So plus 31 gets us to August 1st. 6 weeks is more than 31 days, right? 6 weeks is 6 times 7 days, so that's 42 days. So 31 days gets me to August 1st. I need 42, so that's another 31, 41, 42, that's another 11 days. 11 days past August 1st is August 12th. So for what dates will the water level not exceed 21 feet? From August 12th onward. Right, so they actually give you a multiple choice here. Oh, that's lame. I purposely didn't look at this first, but I answered in more detail than they wanted. Right? The water level will not exceed 21 for the dates at most blank weeks after July 1st. Okay, let's get back to here. We're saying W is greater than or equal to 6. So let's just write that here. W is greater than or equal to 6. In order for our conditions to be met, our number of weeks has to be greater than or equal to 6. So the water level will not exceed 21 feet. Right? Notice this is the same for all 4 options, right? Because that's what they said. Will the water level not exceed 21 feet? So our condition will be met for the dates 6 weeks or beyond. So at most 6 weeks, no. If the date's earlier than 6 weeks, no. If the date's at least 6 weeks or later than 6 weeks, okay. At most 6, we're saying 6 weeks or fewer. We're saying 6 is the upper limit. We want 6 to be our lower limit, so that's wrong. Earlier than 6 weeks, we're still saying 6 is the upper limit, but we're not including exactly 6. It could be 5 weeks. All right, that's wrong. At least 6 weeks. 6 weeks would work. W is greater than or equal to 6, yeah. At least 6 or more. Here we're saying 6 is our minimum value, and it could be more than that. For the dates later than 6 weeks, we're excluding 6 weeks exactly. Well, we included 6, so we have to include 6. This is our choice with the 6 in there. So we're not filling in 6 here. We're ignoring A, B, and D. They're all wrong. We're selecting C at least 6 weeks after July 1st. We're all good. And we actually calculated that August 12th is 6 weeks after July 1st. So there you go. All right, we're still modeling our problem with an inequality now instead of an equation, because we're not looking for exactly meeting our criteria. We're looking at whether we're exceeding or being less than, all of that. So we get an inequality, we still solve it the same way, and then we answer the question.